Muscles are truly remarkable tissues. They constitute a significant portion of our body mass, enabling us to move, maintain posture, and perform various physical tasks. From the seemingly simple act of walking to the awe-inspiring feats of elite athletes, our muscles are constantly at work. Understanding how muscles grow and adapt is crucial for anyone looking to enhance their physical performance, improve their overall health, or simply marvel at the intricacies of the human body. Muscles are not static structures, they are dynamic and responsive, adapting to the stresses placed upon them. This adaptability is the foundation of muscle growth, a process known as hypertrophy. When muscles are challenged with resistance training, they undergo microscopic damage. This damage is not detrimental, but rather a signal for the body to repair and rebuild the muscle fibers stronger than before. This continuous cycle of damage and repair is the essence of muscle growth. Before delving into the intricacies of muscle growth, it's essential to understand how muscles contract and relax. Imagine you're opening a door. Your brain sends a signal to your motor neurons, which are specialized nerve cells that control muscle movement. These motor neurons transmit the signal to the muscles in your arm, causing them to contract. Muscle contraction is a fascinating process at the molecular level. Muscles are made up of long, cylindrical fibers that contain even smaller units called myofibrils. Myofibrils are composed of two types of protein filaments, actin and myosin. When a muscle receives a signal to contract, the myosin filaments attach to the actin filaments, forming cross bridges. These cross bridges then pull the actin filaments closer together, causing the muscle fiber to shorten and generate force. As you push open the door, your arm muscles contract, shortening and pulling on your bones to create movement. Muscle relaxation is simply the reverse of this process. When the signal from the brain stops, the myosin filaments detach from the actin filaments, the cross bridges break, and the muscle fiber returns to its original length. This coordinated dance of contraction and relaxation is what allows us to move our bodies with precision and control. Now imagine trying to open a much heavier door, perhaps a massive iron-wrought gate. Your brain senses the increased resistance and recruits more motor units to generate the necessary force. This is the principle of progressive overload, the cornerstone of muscle growth. When you consistently challenge your muscles with heavier weights or increased resistance, you force them to adapt and become stronger. Progressive overload ensures that your muscles are constantly pushed beyond their comfort zone. As you adapt to a given workload, you need to increase the challenge to continue stimulating muscle growth. This can be achieved by gradually increasing the weight you lift, the number of repetitions you perform, or the frequency of your workouts. Section 4, Microscopic damage, macroscopic results. As you subject your muscles to progressively heavier workloads, you are essentially inflicting microscopic damage to the muscle fibers. This damage, while sounding alarming, is a crucial part of the muscle growth process. When muscle fibers are damaged, they release inflammatory molecules called cytokines. Cytokines act as signaling molecules, alerting the body to the presence of damage. This triggers a cascade of events that ultimately lead to muscle repair and growth. Think of cytokines as messengers that rally the body's repair crews to the site of damage. These repair crews, consisting of specialized cells, work tirelessly to repair the damaged muscle fibers and build them back stronger than before. Section 5. The recipe for muscle growth. Muscle growth is a complex process influenced by a multitude of factors, including nutrition, hormones, rest, genetics, age, and gender. Consider these factors as key ingredients in the recipe for muscle growth. Just as a cake requires the right proportions of flour, sugar, and eggs, muscle growth relies on the optimal balance of these crucial elements. Nutrition plays a vital role in providing the building blocks for muscle repair and growth. Protein, in particular, is essential as it provides the amino acids necessary for muscle protein synthesis. Adequate calorie intake is also crucial, as it ensures that the body has enough energy to fuel the muscle building process. Hormones act as chemical messengers, regulating various bodily functions, including muscle growth. Testosterone, often associated with masculinity, plays a crucial role in both men and women for muscle protein synthesis. Growth hormone, as its name suggests, is involved in stimulating muscle growth and repair. Rest and recovery are often overlooked but are as important as exercise itself. During rest, the body repairs damaged tissues and replenishes energy stores depleted during exercise. Sleep is particularly crucial as this is when the body releases growth hormone and facilitates muscle repair.